Welcome to Schematic Capture in Altium Designer. In the first module, we created a project and added both schematic and PCB. We will now start the schematic capture phase of design. In our expansion board project, we will add another schematic. In this instance, we will take advantage adding an existing schematic to the project. If a schematic exists that has what you need or close enough so that it requires little or no effort to be completed, this can save a lot of design time. To add an existing schematic to the project, we will need a local copy of the schematic in the same folder as the project. This was already done, and we have the schematic open under the Free Documents section. If the schematic was not opened, we could pull it into the project by right-clicking on the project file and selecting Add Existing to Project. A faster way, given the schematic is already open, is to drag it into the project, like this. Now we should save the project file to update it with the new schematic. Let's look at the properties for this newly added schematic. With nothing selected, the Properties panel shows the generic information for this sheet. We will want to edit some of the parameters, including the title and revision fields. To do so, select the Parameters tab in the Properties panel and scroll to the Revision field. Click on the field and enter a revision number. Next, scroll down to the title field and enter SBC_IO. Now we can see those parameters reflected in the title block for this schematic. In this case, we have an A4 size sheet. This is a standard template with predefined fields. By selecting the drop-down arrow, we can see all the different sheet sizes and schematic templates available to choose from. There are still some undefined parameters, namely sheet number and total number of sheets. These are system parameters. Now that we have all the schematics in this project, we can update these parameters. To assign sheet numbers, click on the Tools pull-down menu and select Annotation and then Number Schematic Sheets. We won't get fancy here and we'll just click on the Auto Sheet Number and then Auto Document Number and Update Sheet Count buttons. This will assign sheet numbers and fill in the total sheet count parameter. Click on OK to accept these updates. Now, switching to the expansion board schematic, we will first edit the sheet parameters. We can now start the process of adding components to the schematic from installed existing libraries. We will place a surface mount resistor from the Miscellaneous Devices library, which is pre-installed with Altium Designer. To speed up searching for a particular component, we can enter the part name, in this case, Res. This causes the components with Res in their name to be displayed and highlighted. We will pick the surface mount resistor Res3. Now we can perform placement of the selected part by right mouse click and then select Place. Moving the mouse over to the schematic, we see the part attached to the cursor. Hitting the Tab key pauses the placement operation and allows us to edit the part's designator. We will enter R1 to illustrate a handy feature of Altium Designer. Hitting Enter exits the pause mode. While the part is attached to the mouse, if needed, tapping on the spacebar will rotate it 90 degrees. Holding the Shift key down and tapping the spacebar will rotate it in the opposite direction. We can place the resistor R1 by left mouse clicking. Notice we have another resistor attached to the mouse, with the designator auto-incremented. We can carry on placing a number of resistors this way. To exit placement mode, either click the right mouse button or hit Escape key on the keyboard. In Altium Designer there are two pre-installed libraries, Miscellaneous Devices and Miscellaneous Connectors. By selecting the Library Files tab and then selecting the Installed tab in the Available File-Based Libraries window, we can see the two pre-installed libraries. If we had other libraries we wanted to add, here is where we would do so, by clicking on the Install button and navigating to the location of the library. For now, we can close this window. The integrated library files have an extension of .intlib and contain both schematic and PCB footprints. Note, there can also be local project-related libraries. These would be available in the project's list of files. However, we do not have any project-related libraries for this project. If you do not have access to a local library with the components you need, with Altium Designer there is an option for accessing an online parts library called the Altium Content Vault. To access the vault, you must have valid Altium Live login credentials. To open the Altium Content Vault, go to the Panels button and select Explorer. Resize the Explorer panel so that we can see all of the information available. We will use the Altium Content Vault to find and access some of the parts for our design. To find a component, click on the Search tab and then enter the part name. Here we are looking for a part PCBDESIGN. This is a CAN bus ESD protection device. In the Altium Content Vault, we can see a lot of detail for the components, including footprints and schematic symbols, as well as links to datasheets. Right mouse click on the part entry and select Place to add this part from the Altium Content Vault to the schematic. To further explore this panel, hit the F1 key for the online documentation. We will place the protection diode on the schematic and continue with the search for a few more parts. This will include MCP2515 and the MCP2551. We will scroll through the available package options until we find the device we need, and then select the part, then right mouse click and select Place. Looking at the SBC I/O schematic, we see several ports and net labels. Selecting a net label, we can see its properties in the Properties panel. If desired, we could edit it here. Likewise, selecting a port, we can edit or update its properties. In this case, CAN_INT barred to the type of I/O input type. This brings us to an important point regarding connections on a schematic and between schematic sheets in a project. Net labels only connect on the sheet that they are on and do not provide connections between schematic sheets, whereas ports provide the interconnections between different schematic sheets in a project. This is a very important concept and one that we will revisit. Now at this point we will jump ahead, skipping over the repetitive steps of placing components from the different libraries. We can now shift our focus to adding wires, net labels and ports. We will start by adding power and ground ports. As previously mentioned, power ports provide global connections spanning all project schematics. Right-click on the ground icon in the active bar menu and select the port +5. Now hit the Tab key and change the name of this port to 5V so that it matches the 5V port on the SBC I/O schematic. Hit Enter and then place the port, if needed, rotating it using the spacebar. With the port still attached to the cursor, hit the Tab key so we can edit the port name to 3V3 and place it just on the CC2 capacitor pin. Right-clicking again on the ground icon in the active bar menu, we can select the port GND. One thing to note, the tool remembers the last used port, aiding additional placement. This helps to continue placing the needed ground ports. We can add a wire automatically by selecting the port and moving it over to the component and placing it directly onto the pin. Then, by holding the Control key, select and pull away the power port to auto-create a wire. Placing wires manually is done using the active bar menu Wire option. Right-click and select Place Wire. Now we are in the Adding Wires mode. Left mouse click on the start of the wire and then move the mouse to place the next wire vertices and left click again. A single click ends the wire but keeps you in wire mode for placing additional wires. Also, whilst placing a wire, hitting the spacebar will flip the vertices of the active wire segments if required. Let's add some badly routed wires to illustrate how we can edit them. Individual wire segments can be moved by selecting and grabbing them with the mouse and moving them as needed. To add net labels for circuit readability or for on-sheet connections, right-click on the wire icon and select Net Label. Before we place the label, if needed, we can rotate it using the spacebar. or if needed, use the Tab key to access the Properties panel to change the label to the desired net name. Hit Enter to place the edited net label. Here we illustrate a connection using net labels instead of a continuous wide connection. In this case, CAN_TXD. These two wires are connected because they have the same net label and are on the same sheet. To connect pins on this schematic to the SBC/IO schematic, we will need to add a port. Click on the port icon on the active bar menu and then hit Tab to edit the name if needed. The name is used to provide the connections. These must match exactly. If needed before placing the port, we can rotate it using the space bar. When placing the port, the first click starts the port and the second click defines the length of the port symbol. Adding a single backslash to the name adds an overbar to the port name. This is enabled in the preferences under the schematics. Graphical editing enables single negation. We can resize the port to show the negation bar by clicking on one of its vertices and dragging. We would continue to add wires, net labels and ports as needed to finish the design capture. This is what our design would look like at this point, with everything wired, ports added and nets labelled. This would be the entire design. We can also add text strings to the design to identify the 3v3 and 5V sections of logic using the place, text string option and hitting Tab to edit the comments before placing. This completes the part placement, wiring, net labels and ports needed for the design. In our next module we will compile the design.